Welcome back. We're writing Little Man Computer in C++. We've got through the first stage of our assembler where we've where we've handled single instructions and their addresses. I said last time that we can move on to looking at the dat instruction, which is kind of slightly different in that, if we have a look here, in that we can have numeric values here instead of label lookups. And in principle, I think these can probably be numeric values as well, but it's more common, I think, in the data instructions. But I think it might be a slightly better way around to handle multiple instructions first, and to get rid of this this slightly annoying slightly annoying check for a trailing halt instruction. We've almost, I mean, we could almost refactor as is now to some sort of looping construct that doesn't require us to have this if statement on the end. But I think I'd just like to stick one extra test in for a sequence of instructions. Slightly longer sequence of instructions that will just make sure we're putting in the right loop there. So if we go to our tests, like so, somewhere in here, and I will just copy and paste that because I trust it pretty much, and it's small enough to not worry, to not be able to miss too easily something that's wrong. So if we have something like an input followed by an output instruction, and a halt is translated to 901, 902, 0. And we can do this relatively easily in out. That doesn't have a value, that doesn't have a value. I'm not overly worried about allowing for there to be address translations in here. I think we've covered that pretty well with the other tests now, and we're not likely to land ourselves in trouble for the time being. So I think this is reasonably safe. So we've got an input and output instruction followed by an input followed by an output instruction, and a halt instruction is translated to this sequence of addresses. I think that's going to be okay. And if we were to run the tests here, we should only fail on that one test, because I believe all the other tests were passing before we started. And if they weren't, then I will be a little bit sad that I'd let that slip through. No, just the one failure, it's the last one. So if we go back to our production code here, we should be able to do something along the lines of, for I equals 0, that's going to have to be that. Because of the way vector sizes work, I think. I is less than instructions.size plus I, and then I think we can just do this, indent here, that becomes I, and we can get rid of the trailing halt. Now, was it as simple as that? Feels like it should be. And if that turns out to be the case, then we'll be able to move pretty much straight on, and it is, to dealing with the dat instruction. So that's all nice and clear, isn't it? We have a lookup table for all of our instruction types. We will add dat to this shortly. We have a loop around each of the instructions with a mechanism for translating that gradually builds up a program which is returned. Now, the thing we're going to run into now with looking at the dat instruction is that this labels lookup is not going to be quite what we want to do, because we want to check first if this address is a number, and if it's a number we want to return that literal number, otherwise we want to return the value in the labels. So I think that's okay for now. Let's just commit our change here, which should be straightforward. Assemble multiple instructions like so, and if we then go back to our tests, we can look at dat instructions. Now I'm tempted to write what I think, given the way we've written things, is going to be a passing test straight away, and I'm kind of going to do this intentionally, and it's not the kind of thing you're supposed to do. But I think I want it just sitting there, minding its own business. So we want to have something like an input. Input is fine here. It's not a relevant piece of information, and a halt followed by an empty dat is translated to that formation here. So I'm not going to label this dat because it's not necessary here, but I believe the way that, and I will check this in a second if there's any clarification on this, that if you have an empty dat here, it's treated as a 0. Yeah. So here, for example, we've got a labeled 0 dat with the comment constant value of 0, defaults to 0, mentioned in all of the comments there. So that's good. But I have a feeling that that test will just pass because of the way that the map works. When we look up the dat instruction, I think we ran into that last time when we were playing with the coffee break. Yes, that just works. What I will do, and this is slightly dubious, is refactor it to that, so that the dat instruction, if we do change the way that the map works, and this is a legitimate refactoring here because we haven't changed the behavior of our program. But if we were to change the way these maps work when we're looking up the code, then I don't want things to start breaking all over the place. So I think I'm happy with that as a sort of pseudo refactoring thing, like that. So then we can move on and write a proper failing test for dats, which will look something like a dat with value 1. It's translated like this. So now this, nearly got it wrong. This should be translated, as it stands, this will be translated to 90100, I believe, because of the way these empty things are handled. These non-entries in the map are handled. So that should fail, and then we can look at something in the way of handling that. And I am going to take this a little cautiously because I don't know how directly how to do this. So what I want to do, I think, I will do this in line and then refactor. So I want to say if instruction.address is equal to 1, we're being very very simplistic about this, making it pass in the right way. That's the variable declaration scope is awkward. So what I'm going to actually say is if instruction.address equals 1, then 1 else that. I think that will do the job. It's not going to stay like that for very long, but it does at least give us a starting point for checking. And I want to refactor to some sort of proper check for this being a number, and that does indeed pass. So then we need to write ourselves another test that gets us a little bit nearer. So if I continue in the same vein, like so, with value 42 is 42, 42, and 42, and this should fail because we've just got the one check, and it's checking for 1, and we'll end up with a 0 again. And we'll then need to start doing something a little bit more intelligent on this. So first things first, we need to make it pass. Is there a nice way of saying, is this string a number? Is that in the standard library? C++ test string for, is number, is integer, whatever. Our good old Stack Overflow. The most efficient way would be to iterate over the string until you find a non-digit character. If they ask for something... Okay, no. So, the C++ 11 way. Yes, we want to do it the C++ 11 way. I'm surprised that there is a standard library check. Is that nice? Is that not nice? Let us just add a little, see if there's anything newer. How to check whether an input is an integer. That's not got a very good... So in string, the standard library provides a set of functions for extracting numeric values from their character representations in a string. Use check P if whole string was read. It is integer. S to float. S to anything fails, it is a string. Have we done? Yeah, you could do that, but we have this as a variable already. That seems a little bit messy. S2I. So S2I C++. Let's see what the documentation says. It might be straightforward. Okay. So on success, the function returns the converted integral number as an int value. And if no conversion could be formed, an invalid argument exception is thrown. That's really quite horrible, isn't it? I don't really like that. And their example doesn't do the checking either. I want something better. Is that not a thing? Yeah, that's just a long discussion of nothing of interest there. I want to see someone actually doing it safely and telling me what I should be doing. I'm sure you do use cookies. That's very nice of you to mention. Yeah, nobody's checking the answer properly. I feel like I might just do it the old-fashioned way, like this, and say, is it a number by, oh, is even in his digit. I did not know that was a thing. That's kind of useful as well. This is not very nice, is it? This is nicer. So, what? Find first of not equals string. Some of these are just are not being very nice. C++. It's my view of C++ at this stage in my learning is that none of these look particularly pretty in comparison to other languages. But I suspect that's just a familiarity issue to some degree. What? That's slightly bizarre. Wait, this looks... for non-negative integers, I would use something like this. std all of. V in end is digit. The not... Yeah, there's a not empty thing here. I'm actually going to... I'm actually just going to steal this, am I? Yes, let's work with that one and see if that works. So we want to have our little static bool is number. That's not the naming convention we're working with today. With const std string s. I'm happy with that as a naming convention. Then return not s empty and what's the all of. I wonder if this is going to work. S.begin, S.end is digit. Have I done that the right way? Sure, why not? Let's give that a go. It'll tell us relatively quickly. That's also not quite what we're after, is it? No, that's fine, because we can do some sort of conversion function. So let us change this to be is number. Now, hoping that will still just fail the one test and not blow up. No member is digit. Do we need to include something? Is digit does not have an underscore, that's why. Yeah, that didn't really do the right thing. That's fine. Oh, no, that was the right That was the right line. I don't know why I'd... dear, have I quit the wrong thing there? It's all gone pear-shaped. Right. Assembler.cpp. That's okay, good. Yeah. So, back to where we were. There's far too many key presses to get there, but hopefully that'll compile and work on the first test and fail on the second test, if our isDigit check is correct. We will find out. Excellent, that's good. So then we need also to then do, that should just be A to I of instruction.address, little verbose there. I don't know if I've quite done the right thing there. I haven't. Oh, no viable conversion from string to const char style. What's the mechanism here? How does one actually convert? Oh, I've got to do reading number or not. I wrote the function below and believe it was working smoothly. Yeah. So, cstra. Is that the best way? Convert string to int in C++. Oh, is it S to I because it's string. What's going on here? So S to I. These are all strings. Let's do that. I think it's going to be faster just to do this rather than worry about being correct. Test passing will do for now. This is just making everything green, and we can tidy things in a little bit. Okay, excellent, that's passed. I'm happy with that. So that's something I'm pretty happy with. Pulling out the address twice is not, 3 times in fact, it's not brilliant. So what if I were to do this, like so. That shortens things a bit. And hopefully keeps everything passing. Seems to be compiling correctly. Everything still passes, that's good. Excellent. So we've got our mechanism here. How are we on this? Does this look okay? Is number, if it's a non-empty string and and all of between begin and end is digit. I think that's the clearest of the things we've stolen from Stack Overflow. And then we pull out the address here. Not strictly necessary. This will be rectified by the optimizer, I would imagine. And then if it's a number, we S2I it. Otherwise, we pull it out of the labels list. Yeah, I think I'm happy with that as being relatively clear and probably not even needing to extract a function to deal with that, which is useful. Good. So test pass. That's good. Let's look at our status. Yep, that's fine. Git commit am handle assembling dat instructions. Good. So if we go back here, next time, how far did we get? We can read all the instructions and we can translate them. So next time we'll need to move on to looking at the preceding two halves of this process, creating that label lookup, which should be the easier of the two, and taking the strings from the source file and breaking them into their component instruction parts, and which should be fun.